Okay, ladies and gentlemen, tonight we start our lab. Our first lab is going to be magnetic particle inspection, and this is basically a simulation lab. In your lab manual, it's experiment 1.2. If we were in class and we were in live session, basically everyone in this class will be doing a hands-on examination of the two parts that we're going to be inspecting, and you'll get a chance at seeing how to utilize the magnetic yoke, apply the colored iron powder, and also then puff away the excessive powder and see how the magnetized iron fills in the gaps where there are defects. So we basically have two samples. The first sample we're going to be examining is what we call a slip coupling. It's roughly a 2-inch long by 1/2-inch diameter hollow sleeved coupling. What I mean by a coupling is where you basically slip in on both sides a piece of pipe to join the two pieces of pipe. And then you, in this particular case, you would use this as a welded fillet weld. Now in this slide, as you can see, there's the magnetic yoke that's pointed to on the right side of the figure, and you have the arms which are flexible, and the power button is circled on the lower left, where you hold the button in and it magnetizes the part. Now you can see there's a rod being used, and the coupling is placed on the rod. The reason we use the rod is because the coupling is kind of small to get in between the two magnetic arms, but also it allows for a way of spinning, if you would, the coupling around as you apply the powder looking for the defect. Now, once you complete the examination, this is what you would find. You would find a Y-shaped figure as it's shown with the blue circle, and it's labeled defect, and it's roughly 3/4 of an inch away from the right edge of this coupling. Now, when you're going to be drawing this up, when you're going to be including this in your results section, you're going to be basically making a front view and a side view of this piece in orthographic projection. Now, keep it in mind, well, I'll wait to the end. I'll go over orthographic projection for those who forgot what it was. Hopefully everybody's taken AutoCAD and you have access to AutoCAD to put it on in your report. If not, you're going to have to, you can either use WordArt or, go insert and use the different figures in Word, or you draw it up on graph paper using a straight edge and, labeling it and then scanning it in or taking a picture and inserting it into the report. Here's a close-up of the Y-shape defect that we found on the coupling. Now the second piece is what I call a weld tee, and this weld tee is basically two metallic plates that are welded together to form a T, and there are welds on both sides of the vertical plate. Both plates measure 7 inches long by 4 inches wide and 3/8 of an inch thick. One leg on the flat piece and one leg on the vertical piece to magnetize basically cause a magnetic field on that welded area. You would then sprinkle your iron powder on and then puff away the excessive powder, and you would see how it would find the defect because it would fall into the open areas. Now you may say, look, this is visible to the naked eye. Yes, it is. We tried to get a weld made when I was with the gas company, and I had my welders try so hard to come up with hairline cracks and stuff, but they really couldn't. So I just told them, make choose the expression, a lousy weld. And so the students can see how the magnetic particles can fall into a defective zone. And you can also see how the length of the plate is 7 inches. I put a ruler there. Again, here's another view looking from the top. You can see where the defect is in the blue circle. And it also shows you the width of the plate as being 4 inches. Another view, again, the vertical plate is 7 inches long and it's 4 inches high. So this way, when you do your orthographic projection of the weld tee, you can see what you have here. My recommendation is to make a front view and a side view again of this tee. And in the front view, just circle the area, try to show some squiggly lines for a weld and just circle the area where the defect is. Again, another view of the defect, looking from the top front. Again, you can see where the defect is in the weld. And I put the ruler there so you have some dimensions. So it looks like it's about 3 1/4 inches from the left side, and about the second one looks like it's about 4 inches from the left side. So we would want to dimension that. So those, if we're in the lab, that's what we'd be doing. We would have a sketch on the board. You would put all your dimensions in. So what do I require for the report? This is the results section of the report. Again, draw an orthographic projection. If you don't remember what an orthographic projection is, it's usually looking at a part and you're looking at it and making it a flat surface. And if you're not sure what I'm talking about, take a look at the presentation I did on how to write a report. In there, I actually have a orthographic projection of the slip coupling and the weld tee. So you got an idea of what to look for. Now, these orthographic projection views, this is not a design drawing. You want to show overall dimensions, just like I said. For the coupling, front view may be labeled a 2-inch length. You show the defect and you give a dimension of the defect from the right edge. In the side view, you show the diameter. The wall thickness of this hollowed cylinder is approximately 1/8 of an inch, if you want to show that. For the weld tee, the same thing. You show the front view, so you would have like a small rectangular box on the bottom, and then you would have a large rectangular box on the top for the front view. You can indicate that there's a weld seam there, and then you can circle where you found the 2 defects, and again, measure them off like I showed in that one slide from the left side. Now, I will be forwarding you guys the PowerPoint presentation so you can have these pictures, so when you're drawing it up, you can see. Again, refer back to the presentation on how to prepare a lab report. I believe it might also be in the lab manual. If you bear with me a minute, I'm going to pull out my lab manual and take a look and see. And let's see, that would be on page 5 of the lab manual. I actually have how you would draw an orthographic projection. Here I'm showing the front view and the top view of the tee. You can use the front view and the side view of the tee. It would give more of a representation of what a tee looks like. But either way, you get an idea. Take a look at the sample results on page 5 of your lab manual, and you'll see what I'm talking about. It's also, again, in the presentation. And if you don't know what page we're working on page 9 of the lab manual, experiment 1.2. It gives you the procedures. It tells you what the equipment we're using. And as far as the sample goes, it doesn't really tell you, but you will indicate that you're examining a slip coupling and a weld tee part. Now, if there are any questions about this, again, we could try to use the discussion section on Blackboard where you can put up your question. But also what I would suggest, because I'm not sure how that really works yet, again, I'm not that 100% familiar with Blackboard. I'm still learning myself. Email it to me. That's the simplest way, but also try doing it on the discussion, putting up the discussion section and see what happens. Okay, so hopefully we can get this done. Now, this lab report will be due next session. The next time we meet for the Wednesday class, which is getting this first, will be due on September. I'm just looking at the calendar right now, so bear with me. It will be due on September 9th. And for the Tuesday class, which will be receiving this on September 8th, it won't be due till the 15th, September 15th. Okay, so hopefully that is very clear to you. Again, if it's not and you have questions, feel free to ask me. I am always available on my emails, and that's it. So this is the end of this presentation at this point. Thank you.